Introductory Algebra Homework Day 33. Starting out, we're going to factor a quadratic with a leading coefficient of 1. When they talk about a quadratic expression, they're talking about an expression with a squared term in it. So I'll see something like a z squared or an x squared. That'll be the highest exponent that you have. The leading coefficient of 1, if you remember, the leading coefficient is the number in front of your leading term. Since this is just a plain z squared, it's a 1z squared. So they say it's a leading coefficient of 1. If I want to factor that, I have to recall that when I do factoring, I'm trying to say what times what gave me this answer. And when I ended up with 3 terms, it came from FOILing. So I know that I had to have my 2 sets of parentheses. So I'm going to start and I'm going to factor the first term. Factor first term, which in this case is the z squared. What times what gave me a z squared? Well, I would have had to have a z times a z as both of my first terms in order to get z squared. Z times z is z squared. The next thing you're going to do is figure out your signs. The way to figure out your signs is if the end is a positive, both signs have to be the same as the middle sign. If the end is a minus, you're going to have 1 plus and 1 minus. So the end sign came from multiplying the 2 end numbers together. If it's a negative, I have to have a positive times a negative. If it would be a positive, it either have to be a positive times a positive or a negative times a negative. So in this case, my end sign is negative. I know I'm going to have 1 plus and 1 minus. And then I just didn't leave myself enough room to factor the end number. I'll smush it down here. Factor the end number. So in this case, I have a 12. 12 is 1 times 12, 2 times 6, or 3 times 4. I want to find the pair of factors that when I end up FOILing this out, I'm going to get a minus 11z in the middle. So if you look at the Alex explanation, they're going to have a whole bunch of stuff written there. But what you're looking at is if I add and subtract these numbers, which pair would give me a minus 11? If I happen to have a plus 1 and a minus 12, a positive 1 minus 12 is the minus 11 that's in the middle. I can always check these answers by FOILing them back out to see if I get what I started with. Z times z is z squared. Z times my minus 12 is minus 12z. 1 times z is a positive 1z. 1 times a negative 12 is a minus 12. My middle term should add up to the middle here. Negative 12 plus 1 is the minus 11z in the middle. So that when I multiply this out, this is what I get for my answer. When you enter it in on the computer, you're going to enter in your factors. In parentheses, z plus 1 times z minus 12. Now this is one of these problems that I do them differently than on the Alex program. So I would suggest that either when you're on this problem, if you go to explain, if the explain wants to come up, nope, doesn't want to. It wants me to refresh the page. We'll try it again. That you go to Linda's note sheets. Linda's note sheets. Otherwise, if you look at the top of your page at the name of it, it'll say IE 27, factoring a quadratic with leading coefficient of 1. If you go under your resources, that's the other place you can get to Linda's note sheets, but you have to know what the numbering was, which you can tell by looking at the name of the topic. And then you'd have to scroll down and find it. IE 27, there it is. And again, if you open that up, it will give Linda's notes and the steps that I did in order to figure out which pair is going to be, or which way I want to factor that. So this is one I would definitely probably print out my note sheets because it's going to be different than what Alex does. Let's go back to our paper here. So number 2, if I want to factor that, I look and say, oh, it's got 3 terms with a squared. I know it came from foiling. Factor the z squared. Well, z times z gave me z squared. I'm then going to figure out my signs. The end sign is a positive. That means both of my signs had to be the same. So I look at the middle one. I had to have a positive times a positive. Then I'm going to factor my n number. My n number is 15. 1 times 15 or 3 times 5 is the only pair I'm going to have in order to get 15. I want the pair that's going to give me an 8 in the middle. So I look here, I'm going to add my 2 things together. Which pair adds up to 8? Well, the 3 and the 5 would add up to 8. And then, if I want, I can check. So I FOIL it out. Z times z is z squared. Z times 5 is a positive 5z. 3 times z is a positive 3z. 3 times 5 is a positive 15. The pair in the middle add up to the 8z in the middle of this expression. So z plus 3 times z plus 5 is going to be my answer. So my quick check is to say, okay, if I do a plus 3 and a plus 5, yep, that adds up to plus 8. Factoring the next one. Again, it's a trinomial, has 3 terms, has the squared, so I know it came from foiling. Factors of the first term, y squared, y times y. My signs, this one again, the end is a negative, so I know one's a plus and one's a minus. Order doesn't matter, just so you've got one of each. I want my factors of 9. Could be 1 times 9, could be 3 times 3. I want the pair that when I plug them in, I get a plus 8. So if I want to get a plus 8, my bigger number has to be positive. If I do a 9 minus a 1, plus 9 minus 1, that should give me plus 8 in the middle. Again, we can always check these by foiling. Y times y is y squared. Y times negative 1 is minus 1y. 9 times y is a positive 9y. 9 times a negative 1 minus 9. The pair in the middle, negative 1 plus 9, gives me the positive 8y, which is what I want in the middle of my expression there. So y plus 9 times y minus 1 is going to be my answer. The third one again, I'm factoring a quadratic with a leading coefficient greater than 1. That means you're going to have a number in front of your squared term. It makes your factoring a little bit more difficult because we have to think about the foiling. Again, I would probably print out my note sheets on this. It's going to pretty much look like the note sheets on the first one. I look at it, there's 3 terms. One of them is a squared term, so I know it came from foiling. But this time, when I factor my 3z squared, I have to figure out, well, what times what is 3z squared? Well, 3 is 1 times 3, so I'm going to have a 1z times a 3z, or z times 3z. Again, the order that you put them in there really doesn't matter. Eventually, it'll work out in the right order, hopefully. But I have a 1z and a 3z. My rules for my signs, the same as on the previous ones. If the end is negative, I know I have to have 1 of each sign. The problem is it will make a difference here which way you put them in. So what you're going to do is just pick one way to put them in, 1 plus and 1 minus, and if you get the right middle number but the sign is wrong, then switch your signs around. So I'm just going to guess and I'm going to make this a plus and a minus because I know I have to have 1 of each. Factors of 7. Well, in this case, there's only 1 times 7. But again, it makes a difference if I put the 1 first or the 7 first. And so what I'm going to do is I'm going to plug them in, the 1 and the 7, and then I'm going to check. So when I'm checking, I could FOIL the whole thing out, but just the quick check is to check what is the outside product plus the inside product, because that's the pair that's going to make up the middle. The outside product here would be negative 7z. The inside product would be positive 3z. But negative 7 plus 3 is not going to be anywhere near 20, which tells me, oh, I got my numbers in the wrong order. I'm going to switch them around. I'm going to put my 7 here and then my 1 here, and I'm going to check it again. Z times negative 1 would be negative 1z. 7 times 3 is a positive 21z. Negative 1 plus 21 would be positive 20z. And yes, that's what I want to have. And so the z plus 7 times 3z minus 1 is going to be what my answer is going to be. You could FOIL the whole thing out if you want, but the quick check is just check the outside product plus the inside product, because that's the pair that adds up to the middle, to double check. So number 5, if I'm going to factor that, again, I know it came from FOILing. Factors of 5z squared. Well, the only factors of 5, 1 times 5. So z and 5z. Z times 5z is 5z squared. This time my end sign is positive. If my end sign is positive, they both have to be the same. I'm going to look at the middle. I'm going to have a negative times a negative. A negative times a negative, multiply and make it positive, but add up to the negative in the middle. Factors of 6. So my factors of 6 could be 1 times 6 and could be 2 times 3. I've got a lot more choices here. Normally, I will start with the pair that's closest together and work my way out. So I'm going to start with the 2 and the 3. Again, you can kind of plug them in your head, but I'm just going to do, for guessing sake, just put them in and check it out, just for practice. So if I do the 2 and the 3 and I check it, z times negative 3 would be negative 3z. Negative 2 times negative 5z is negative 10z. And hey, that did add up to the negative 13z, so I've got the right number in the middle. If that hadn't worked, I would have put the 3 first and then the 2 and checked it. If that didn't work, I'd have to try the 1 and the 6, or the 6 and the 1. And I just keep checking until I find the right pair that give me this middle number. So z minus 2 times 5z minus 3, going to be my answer. So number 6, again, factoring, we have 2x squared plus 19x minus 21. 2, again, only has the factors of 1 times 2. So we know that our factors of 2x squared, 1x times 2x. So x times 2x is 2x squared. The end sign is a negative. So if the end sign is a negative, we have to have 1 plus and 1 minus. Again, it does make the difference of the order, but we don't know what it's going to be, so we just plug them in, and if we need to, we'll switch them around. Factors of 21. 1 times 21, 3 times 7. Again, usually I'll start with the pair that's closest together, so I'm going to start with the 3 and the 7. And so if I put the 3 and the 7 in there and I check them out. X times negative 7 is negative 7x. 3 times 2 is a positive 6x. Negative 7 plus 6 is only negative 1. I want to get 19. My number is not near big enough. So I try in the other way. I'm going to put my 7 here and my 3 here. And then I'm going to check it out. X times negative 3 is negative 3x. 7 times 2x is 14x. That's not working out because that's only 11x. So now I got to try the next pair. So I go to the 1 and the 21. So 1 and 21. My outside product is negative 21x. My inside product is positive 2x. Well, I'm getting closer. Negative 21 plus 2 is negative 19x. However, we don't want negative 19. We want a positive 19. So that tells me I got my numbers in the right order. I just have my signs backwards. I'm going to change this to the minus and this to the plus. So if this is a minus and this is a plus, then this will end up being positive 21. This will end up being negative 2. And 21 minus 2 is my positive 19 that I want to get. Now I finally, after all that guessing and checking, have them in the right order. And so x minus 1 times 2x plus 21 is going to be my solution. Now these ones we're factoring with a leading coefficient greater than 1, type 1, because they gave you nice prime numbers that only had one pair of factors. Now we're going to do problem type 2, which are going to be a little bit harder, because now we might have more than one choice for our factoring of our leading term. So, I've got 9x squared. If I want to factor 9x squared, it might be x and 9x, but it might also be 3x times 3x. Again, I really don't know which one the answer is until I start guessing and checking, knowing about foiling to figure out which one is the right way. So I have to be aware that there's more than one choice. My signs. Since the end is negative, I know one's a plus and one's a minus. Factors of 3. Well, at least they gave me a nice prime number for 3. 1 times 3 is my only choice. I don't know which order it goes in. I'm just going to start guessing. But because this is a 26, it's a big number, I'm probably going to put the 3 first and then the 1 and try it that way. So if I try the top one, x times negative 1 would be negative 1x. 3 times 9 is a positive 27x. If I do that, I get a positive 26x, which gets me really close to my answer, because instead of a positive 26, I want a negative 26, which tells me that's the right order of my numbers. I don't even need to try this bottom one, but all I need to do is switch my signs around. So this one's going to be the negative, and this one's going to be the positive, so that my outside is a positive 1x, my inside is a negative 27x, and sure enough, there's my negative 26x in the middle. So these ones are a whole lot of guessing and checking and just trying what you know, foiling it out either on your paper or in your head till you can find that right combination that gives you that middle number. Number 8, we have 3y squared plus 16y plus 20. 3y squared, again, I would have y and 3y. 1 times 3, the only way to get 3y squared. My signs, the end is a positive, so both have to be the same as the middle, positive and a positive. Factors of 20. 1 times 20, 2 times 10, 3 doesn't work, 4 times 5. I have a whole lot more pair of factors to check. So, I'm going to start with my 4 and my 5, and then I'm going to check. So here I'm going to say, okay, I'm going to get 5y plus 12y. 5 plus 12 is 17. Not going to be the right way. If I would switch them around, 5 and 4, I'm going to get 4y plus 15y. Well, that's 19. That's still not the right thing. So now I go to my next pair of factors. 2 and 10. 2 and 10 gives me 10y plus 6y. Hey, 10 plus 6 is 16. I found the right pair of factors. So y plus 2 times 3y plus 10 is going to be my answer. These will take you some practice, I guarantee. Number 9. Factoring that again, I'm going to have my 2 sets of parentheses. Factors of 21z squared. Now again, it might be z and 21z, but probably not, because 21 is a pretty big number. The other way to get 21z squared would be 3z times 7z. I'm going to guess that's probably the pair of factors it is, just because that middle number is not really big. Doesn't mean it rules it out totally, but here I'm going to look and say, oh, my signs. One has to be a plus and one has to be a minus. And the only way to get 2 is 1 times 2. I'm going to start with the bottom one because that's my guess is the one that's going to work out right. If I check that, here I'm going to get a negative 6z, here I'm going to get a positive 7z, that's a positive 1, that's not the right way. So then I switch them, put my 2 first and then my 1, 2 and my 1. Here I'm going to get a negative 3z. Here I'm going to get a positive 14z. Negative 3 plus 14 is positive 11z, which is what I want. And so 3z plus 2 times 7z minus 1 going to be my answer. The next ones here, get on the right ones, is factoring a quadratic in two variables with a leading coefficient greater than 1. So that just means I've got both x's and y's. I'm going to have x's and y's on both of my terms. My factoring process, the same thing I've been doing. So here I have a 4x squared. I got to keep in mind that 4x squared could be x times 4x. It might also be 2x times 2x. Don't know which one it is, I just keep going. My signs, my end is negative. If my end is negative, I have 1 plus and 1 minus. Factors of 15y squared. So 15 could be 1 times 15, but probably is the 3 times the 5. But now we've got the y squared, so we've got to put the y's in with our answer. 3y times 5y would give me 15y squared. If I check that one out, I'm going to get negative 5xy, and I'm going to get a positive 12xy, which would give me positive 7xy. Well, I wanted to get a negative 7 instead of a positive 7, so this tells me that's the right pair. I just need to fix my signs. So we're going to make this one the negative, this one the positive, and so I would get positive 5xy minus 12xy, which then is my negative 7xy. And so x minus 3y times 4x plus 5y would be my answer. Number 11, again we're factoring. This time we have variables on both of our numbers. So factoring 2x squared. 2x times x is 2x squared. The end sign again is negative, so we're going to have 1 positive and 1 negative. And then I've got to do my factors for 20. 1 times 20, 2 times 10, 4 times 5. I'm going to start with the 4 and the 5. I got to keep in mind that I got to put the y's on with my values, so 4y and 5y. And if I check that, my outside product is negative 10xy, my inside product positive 4xy. Negative 10 plus 4, not 3. So I switch them around. I'm going to put my 5y first and then my 4y. 5y and 4y. So my outside product is negative 8xy. My inside product is positive 5xy. Negative 8 plus 5 is negative 3xy. Sure enough, negative 3xy is what we want. So 2x plus 5y times x minus 4y going to end up being your answer. Number 12, still factoring. Going to put my two sets of parentheses, factors of 3x squared. 3x times x, or x times 3x, whichever order you prefer. My end is negative. If my end is negative, I know I have 1 plus and 1 minus. Factors of 15y squared. Well, 15 is 1 times 15 or 3 times 5. Trying the 3 times 5 first, I'm going to put 3y and 5y, and then I'm going to check. 3x times negative 5y would be negative 15xy. 3y times x is a positive 3xy, and a negative 15 plus 3 is not 4. And so I got to switch them around. So I'm going to put my 5 first and then my 3. So 5y and 3y. 3x times negative 3y is negative 9xy. 5y times x is a positive 5xy. If I add those, I get negative 4xy. Tells me my values are in the right order. I just need to fix my signs. So I'm going to make the first one negative and the second one positive. Now I'm going to get a positive 9xy and a negative 5xy, which gives me the positive 4xy in the middle. So 3x minus 5y and x plus 3y. The last 5 on here, factoring a perfect square trinomial with a leading coefficient of 1. Now, you don't know that it's going to come out to a perfect square trinomial just by looking at it. You know it looks like those other ones we've been factoring. So we're going to factor it the exact same way as we were factoring the rest of the other stuff. We know we had 2 sets of parentheses. U squared, u times u. The end is positive. If the end is positive, both signs have to be the same. They're both going to be the same as the middle sign, so a negative times a negative. Factors of 16. 1 and 16, 2 and 8, 4 and 4. I want the pair that's going to add up to negative 8 when I plug them in. Well, if I do a negative 4 plus a negative 4, guess what? That's the negative 8 in the middle. What happens with these ones that they're calling perfect square trinomials is you get the same thing twice. So instead of entering it in with 2 sets of parentheses, you're going to enter it in as a perfect square. So u minus 4 squared is going to be your answer. Number 14, same kind of thing. When you look at it on the assessment, it's just going to say factor. You're not really going to know that it's a special one. And so you're going to say, oh, I got to FOIL that out. Factors of y squared, y and y. The end is positive, tells me both signs have to be the same as the middle. The middle sign is a positive, so a plus times a plus. Factors of 49, going to give me 14. Well, I could do 1 and 49, but more likely it's 7 times 7 because we know 7 plus 7 is 14. So a positive 7 and a positive 7 add up to 14 in the middle. Again, we get the same thing twice. So we get y plus 7 squared for our answer. And number 15, same thing. Tells me to factor. I've got a quadratic expression. I'm going to put my 2 sets of parentheses. X times x is x squared. The end is positive. Both signs have to be the same as the middle sign, a plus and a plus. Factors of 1. Well, the only way to get 1 is 1 times 1. 1 times 1. If I do 1 plus 1, adds up to the 2 in the middle, and so I get x plus 1 squared. And so you're doing a whole lot of factoring where it came from FOILing. Basically, all of them you can kind of use the same steps to do. And you can always check your answer by FOILing it back out and seeing if you get what you started with. But basically, it just takes a whole lot of practice.